He had to transcribe that one. Didn't. Yeah, but it didn't do the. Stuff that I can't cover for the workshop.
All good? Coming down from the 34th floor took a while.
Yeah, I had a similar issue.
How are you?
I should have asked the lawyers during the work group chair session. They're keeping recordings and transcripts of everything we say. Are we licensing it to be fed into an LLM as training data?
Did you restrain yourself, or you just didn't
I,
have time?
I didn't think of it until I came into the room.
Okay.
So I'll have another opportunity, I'm sure.
We're gonna have a. They're gonna be talking to the IB tomorrow morning. So if you want to.
Oh, that's true. Okay. Hello, everyone. We'll get started in just a moment. It's already 1:02, so we do need to get moving. So if you could take your seats. If you could take your seats. David Skenazy, take your seat. Thank you. Can you present by any chance? That's what I mean, yeah.
Does everyone have slides?
I think so, yeah. Okay. Welcome to the second session of HTTP. We have a fairly full agenda today because we had to switch some things around. First up, we have security considerations for optimistic use of HTTP upgrade by Ben. Then HB server secondary cert auth by Eric. Those are both active drafts. And then we have four other topics lined up. One that we had to shift from Monday from David. Then we have the Novari search from Jeremy, revising cookies from Johan, and HP resource versioning from Michael. Any agenda bashing? Okay. We need a scribe for this session. Does anyone volunteer as tribute? We do need a scribe. Hi, Martin. We need a scribe. That's everybody's excuse. Alan Frindell.
I'm writing slides for my session, which is the next.
All right, I feel that. That's fair. I feel that. Someone else. I see a lot of presenters, and what kind of cuts them out.
Well, they can always trade off.
Collaborate, yeah, I suppose. Sure. So we have a volunteer, David, for early in the session. If we could find someone to do later in the session. I guess, David, tell us when you need to stop scribing and we'll find someone else. How's that? Remind us. Thank you. Okay, well, that's sorted at least for the time being. Please sign into the session with the data tracker so that we know that you're here. And imagine that there's a large a slide on the screen that says Note Well. If you haven't, by this time in the week, you should already be familiar with the Note Well terms. These are the terms under which we participate in the Ietf regarding things like your behavior, privacy, intellectual property. They are very important. So if you're not familiar with them, please search for Ietf Note Well and understand and read that material and what's linked from it. And if you have any questions about that, you can contact us or any other Ietf leadership. So let's go ahead and get started. First up, we've got security considerations for optimal use of HTTP upgrade.
Actually, do you
Oh.
want to? Yeah, I will.
Do you want to drive your slides or would you like us to?
Who's driving?
Okay, lovely. Take it away.
Confirm.
Okay, hello Httpbis. That's the name of the draft. This was adopted relatively recently, and I haven't really made any changes to it except to add a mention of Connect IP, which should be uncontroversial, maybe. There's not much to say about Connect IP. There are a bunch of proposed changes that I wrote up to try to represent feedback that I got from the working group, mostly during the adoption call. But also then I got a lot of good comments on some of that, and I've adjusted some of those proposals. So I will be presenting the latest version of the proposed changes, that my best attempt to reflect possible consensus of the working group. So first I want to talk about the HTTP and TLS upgrade token. So I went and looked in the IANA registry, and the IANA registry says there's an upgrade token called HTTP, and it takes a version suffix, which can be 2.0. So you can do upgrade : HTTP/2.0, and that is like a registered defined thing. If you want to know what it means, you should see RFC 9110 section 2.5, which is the thing that defines HTTP versions. That's the section about versions. And then there's also actually another one for TLS, and that references RFC 2817. And so I mostly want to talk about the HTTP upgrade token. There's a long story here, but I think the consensus of the working group at a minimum is that this is not a thing that anybody is actually doing. As far as anybody can tell, this is not a deployed thing anywhere on the internet. Nobody's told me otherwise. And so you might say like, well, whatever, it's just some like weird text in the IANA registry, but nobody's really confused about that, and who cares? And I think that's mostly true, but I did find this one thing, which is called http.dev. It's a website with advice about how to use HTTP, and it suggests that to get HTTP2 or HTTP3, you should use an upgrade header and specify HTTP2, not 2.0, just 2, to upgrade. And I would love to be able to email these people and tell them, oh, and by the way, this is not like ancient history from before HTTP2 existed. This page was last updated about a year ago. I would love to be able to email these people and tell them they're wrong, but I'm not actually sure that I can do that because I don't have any standards text that says that they're wrong. In fact, I have standards text that says there's a token, it's called HTTP, and you can upgrade to it. So I wrote a pull request for this draft, and it says basically this. I'm not going to read it. The bottom line is it updates the IANA registry to put in parentheses the words obsolete token. There's been a lot of comments about this. Maybe Mark has comments about it.
Are you ready to?
So, yeah, so let's, I'm happy to stop here and ask for feedback on this change. Martin Thompson and some others have commented on GitHub about questions of like, I'll give you an example. The questions about should we even be talking about this in this draft? Can we somehow punt this into a separate draft? So, but yeah, feedback welcome.
Okay. So just speaking personally, even though I'm sitting here, I'm just lazy. Um, First of all, I don't think we should be acting based upon what random websites put in documentation about HTTP. Long experience has taught me that we will never be able to control all of the text about HTTP written on the internet, and we would cause ourselves great pain if we try to do so. Having said that, I think that a convincing argument can be made if they're receptive. I've had reasonably good luck with sites like the Mozilla, the whatchamacallit, the MDN, thank you, whatever they call it these days. MDN seems reasonable about these things if you engage them, and I think that's generally seen as authoritative by folks who look for stuff on the internet other than in the specifications themselves.
I should possibly clarify that that screenshot I gave you was the only case I could find via search engine of anybody talking about this.
Right.
Did you ask AI?
Bad tummy. Second, I tend to agree with Roy. The registry, should not be updated in a revisionist fashion to reflect current practice. It needs to be a historical document as well. There are many registered things that are not used, and that's okay. And third, I do tend to agree that if we do this, it should be a separate intentional thing, not tied to the fate of this draft. But that's just me personally.
Okay, thank you, Mark. I do want to point out that this is a sticky issue because, in my view, this is a quantum superposition of standard and deprecated, and nobody seems to know what state it's in. But by talking about it at all in this draft, I am going to have to force it into one of those categories. It's either a standardized thing with certain properties that I can discuss, or it's a deprecated thing that that doesn't exist. The only way I can avoid that is by not mentioning it all in the draft, and we can do that. That's another option. We can just skip it. But if we mention the HTTP upgrade token in any way, then that, I think, forces it into a category. I lost slide control.
Oh no.
Mike Bishop.
Just responding to Mark's comment. Oh, is my mic too hot there? Responding to Mark's comment, I don't think we lose the registry as a historical document by indicating that something is obsolete or was reserved and never defined. So, okay, and
Okay, I think we should. Okay, I think we need to move to the next slide, but I've lost slide control.
How do we give
I
him-
can revoke it. I can share the slides.
try to reshare maybe?
Granted.
Okay, the next thing is extending the draft to cover HTTP Connect. So the draft is security considerations related to optimistic upgrade. That's literally the upgrade header in HTTP 1.1. But HTTP 1.1 also has Connect, and that turns out that's another case where the HTTP usage of the TCP flow ends and some other protocol starts using that same flow, and so you have the same problem. And that isn't that surprising that this draft sort of comes out of Connect TCP. But Mike Bishop pointed out that we could cover that as well. One interesting thing about that is that it is actually a deployed thing. And so there are actually known clients out there that do unsafe optimistic upgrade with HTTP Connect today, which means server-side mitigations might actually be warranted in this case to try to paper over the bad behavior of existing clients. So, so that's some proposed text there. I guess the most interesting thing about this is that it's a big change in scope to the point that I think you need to change the title. So yeah, I wouldn't want to make this change without some clear consensus. Mike?
So I just wanted to say the stack that I thought did this, I'm told does not. So I wanted to ask the question, have you found others that do, or is that based on my thinking that there was one?
I can say that as an occasional proxy client implementer, I've certainly considered doing this as a performance optimization. And it didn't at that time occur to me that it was going to create any kind of security problem.
Okay.
I don't know of a specific implementation that does this today.
So that may also be a question for the room. Can anyone else come to the mic and say if you have seen this happen or if your own stack does this?
Over H1.
H1. Okay. So yeah, I really appreciate some more input from the group. This is a big change to the draft. Recommending get. So that I highlighted the only normative part of this. So this is most of this draft. This is only speaking to ourselves. This is telling us how to define our own future standards, and it is saying we should restrict our upgrade tokens to only use get basically in places where the method isn't even meaningful. It's just some kind of placeholder. We needed some method. This is what mask has done. This is what WebSocket has done. And so basically this is just saying, look, for consistency going forward, this is what we've been doing. We should actually remember to keep doing it. There's certainly an argument that this is unnecessary, that we can just do whatever we want in the future when we decide to do it. But there was some feedback on this point. Tommy?
I'm also going to be lazy and not go up to that mic. Tommy Polyapple, I like having this in there, if for nothing else than the fact that, like, when we did this in Mask, it was something that we had to discuss and figure out what is the right thing to do. And it would have been convenient to have something to look at and say, like, oh, this is the obvious thing to do. So having it written down somewhere that we could reference in the future would be nice. And I don't see a reason it couldn't be here.
Can you identify yourself?
Yeah, Michael Tumum. Yeah, on that note, we could change the language to recommends instead of should.
Those are theoretically equivalent in Ietf. If you think it flows better, we can certainly do that.
And I got on cue to say that generally people frown when you place RFC 2119 requirements on things other than implementations. And in this case, you're placing it on a future specification. So perhaps this should be non-normative. And that gets around the problem of, well, maybe somebody wants to do something else and they have a good reason. That's fine.
Okay. Thank you.
Individual. For now.
Okay.
Martin Thompson,
Oh, sorry.
thank you.
So I think you're right. This shouldn't be normative, but I think it is still good advice.
Should not.
I do not want this to be normative.
We were just teetering on the edge of a rabbit
The
hole.
word shouldn't have appeared in that sentence. So
Don't go there.
I think there's two parts to this. There's the fact that it doesn't have a request body, which is key, and then there's the suggestion that you might use a get. And if you could sharpen that a little bit better, that would be that'd be appreciated, I think, because I think people reading this will go, oh, they're recommending that we use get, but I've got this thing that it doesn't make sense for. I think the key is to really put a signpost on the request body part.
Okay.
And say that unless you have other reason to do so, get is totally appropriate. Right. So it's just rewording.
Okay.
And if I can just build on that, I think if it's a recommendation, if we can capture the reasoning behind the recommendation in all of its nuance, then an informed decision can be made in the future. We shouldn't just say, don't do this or whatever.
So there is a sentence at the end on the slide that attempts to do that, but
I can't see
I'm happy to.
Yeah, let's just sharpen that up a little bit. Lucas points out in the chat here that get can has body, but really not. It's sort of pretty much not.
Yeah.
Just don't.
Okay. Martin's off cue, yeah.
Okay, TLS upgrade token. So originally I said we should get rid of the HTTP upgrade token because it's not a thing, and we should get rid of the TLS upgrade token because that's also not a thing. But it turns out that I'm wrong, I guess. And there are some systems, deployed printers, that use the TLS upgrade token, maybe. So instead, we have to talk about the TLS upgrade token, which I believe is safe to send optimistically, because because it can't be mistaken for an HTTP request. If you disagree with my reasoning, maybe we should just take it to GitHub.
I don't think this is particularly important, but I don't think we want to make really strong claims here about this one. It turns out in the past, things that have looked at streams of TCP and whatnot have taken liberties, I should say, about the interpretation of that stream of bytes to the point that they can squint at it and infer things that they really shouldn't have.
So how do you feel about the HTTP2 preamble in that context?
That was a piece of a defensive measure. It's not necessarily considered a definitive defense against that sort of thing. The primary defense that we have in HTTP2 is the use of TLS and ALPN, right? And this is just a defense in depth, if you will. This, again, is probably sufficient in a large number of cases, but we have evidence of middle boxes in particular that would scrub through looking for an end of line and then a get on the following it. And if you had those 4 characters, they would do things. And they would do interesting things as a result. So don't make strong claims here. Yeah, it turns out that you can do that. And it turns out that TLS doesn't protect you from that sort of thing.
Yeah.
Okay, that seems like good advice. And we can rework this to say something else, which is probably don't do this.
Anything else in this draft? I think you're done. Yeah. Okay. Thank you very much. Look forward to seeing more progress in that one. Thanks. Next up, we've got Eric with HTTP server secondary cert auth. Do you want to drive your slides? Or shall we? If it lets you. Okay, let's see how it goes. Doing reasonably well on time.
Yeah. Want to request? So is that on the onsite tool now?
It's
Or
the onsite
full
tool.
client?
Either.
I'm on the full client. I don't know where to do it.
Why don't we drive the slides? I think you only have a couple slides.
Yeah,
So go ahead
should
and
be fine.
kick them off.
Yeah.
Hi, everybody. I'm Eric, and today we'll be talking a little bit about the secondary certificate authentication of HTTP servers draft. So the current status of the document is that it has been recently adopted by the working group. Yay. So it's still early on in the editorial process. There are a few non-editorial issues that I thought we could use a little bit of time here to talk about if anyone has any opinions. So they are listed here and we'll go through them. Next slide. So with that, the first issue that has come up is about the ability for clients and servers to agree upon the used certificate for a given request. I have heard in discussions that there might be some use cases for this like if the server needed to know which hat it was wearing, or the client thinks it's wearing. There is currently no mechanism in the document that actually specifies how this could happen, or even enough information to make it happen. So if this is something that the working group was interested in, and so that's one of the questions, is that like we could reintroduce a cert ID field, which was in the old secondary certs document, which, you know, essentially the server can provide either in the frame or the certificate request context on the exported authenticator. And then the client could essentially tell the server, this is the certificate I'm using, by, for example, providing the certificate ID in a request header. So the big question here is, does anyone actually have a use case or think this is interesting? Is this something that should be in scope in the document? Okay, so we can follow up on the GitHub issue if anyone does think this is important. Otherwise, we could potentially not do something about it. All right, Tommy's in the queue.
Yeah, just as an individual here. So speaking for the use case, which I know you also are aware of, where we would be using secondary certificates from a proxy, like, to be clear, like that is a case where the server is sending the secondary cert based on learning something about previous client requests, but it's not needing to use like a separate frame, like a cert ID. It's like, oh, I've seen that you've been doing connect requests for this thing. By the way, did you know I'm authoritative for it? That's a case where like there is signaling, but it's not a new frame and like it's already present.
Right.
So I think one of the interesting questions would be like, are there use cases that people actually have that they want to build right now that need the explicit signaling? You could also add the explicit signaling later.
Yes. So doesn't seem like anyone is volunteering any use case here. So Eric is in the queue.
Eric Nygren, Akamai. I think the thing that is particularly helpful to know is when a connection's been coalesced onto, because there's and I think there's a blurry line there of whether it's, I'm not sure if it's that you need to know the cert that was used as much as the path you got there. So that could be something in that indicates like which alt service or origin frame or other thing got you there. Because I think the important thing from a lot of server sides is to know I got here versus DNS versus I got here versus some other mechanism.
Right. And I guess if it wasn't directly correlated with the particular certificate, I guess I don't currently have a good answer as far as how we might do that, but we can also discuss offline and, you know, bring it to the GitHub issue as needed. All right, next slide. So the next issue I thought we would talk about is providing the ability to send export authenticators in multiple frames for H2. The thing is that if a export authenticator is sufficiently large enough, there is the possibility that either it doesn't fit in the you know, maximum frame size for H2, and even if we were to give it an infinite, you know, effective frame size, we then block the not just a control stream, but effectively the whole connection. So the question is what we would like to do about this. Continuation frames themselves actually cannot be used because continuation frames are not supported on the control stream, for which the certificate frames go. So one thing that has been discussed is just simply a simple to be continued flag for the certificate frame that, you know, if that frame is received with it. The following frame is a continuation of the previous exported authenticator fragments that you've received up until the flag is not set. We do have to be a little careful here. Things like continuation flood and whatnot mean that we probably want to hash out any possible, implications of adding a mechanism here. So, yeah, it would be good to figure that out. I see Martin is in the queue.
Martin Thompson. I have a strong allergic reaction to anything continuation shaped. Mistakes were made, and unfortunately we can't unwind them. Let's not make them again. Although I'm about to suggest potentially another mistake. Thinking about this a little bit more. So for something like an exported authenticator, the key sort of challenge is, okay, so the signature is going to be big, but the signature is probably not going to be so big. It's not going to fit in a single frame. No, a single signature, which is the primary thing that an authenticator contains, is probably small enough to fit within a single frame. That may be reasonable, I think. But there's often a whole bunch of other stuff that comes with that signature.
Right.
A certificate chain. I'm wondering whether or not we can employ one of the many compression techniques for those certificates that would allow us to sort of break out of this in a way that's a little more accessible. One of the things you might imagine happening here is that you have a set of authenticators that all chain to a common intermediate certificate. And so in a typical exported authenticator case, you would be sending the same certificate chain multiple times. So there may be value in having, say, a small store of this is the set of intermediates, or these are the higher level certificates on the chain that you might reference from an exported authenticator. Of course, it increases the complexity of the thing, but it potentially means that you can replace the entire certificate with a pointer to it. That might be something worth exploring here, rather than doing this. It means you have to set up, I'm willing to take this many certificates and they can only be this big and all those sorts of other complexities around this. But I think it might be a much more efficient and simpler protocol out the other end of that.
Please do.
Hello. Yeah, I'd like to share some of the concerns with Martin about the security issues with continuation like design. I've got no more to add than that. I'm not strongly opposed to it if we really need it, but I want to make sure we've gone through like all of the possible ways this could go wrong and document them if we really decided we needed it. Thank you.
Agreed.
Mike Bishop, Akamai. I will point out that since this is an extension, and extensions can change anything about the protocol, it could also change continuation frames having to be for headers and not being allowed on the control stream. So that is completely within our power if we decide that's what we need to do. I would really like to avoid needing to do that, but it is an option. As far as Martin's suggestion goes, that sounds like a great approach to take if we were building exported authenticators anew. I'm unclear whether we can do that with exported authenticators as they exist without going back to TLS. So I don't know that this needs to go back to TLS if we're able to use what's already there. Just slow everything down.
David Skenazy, I had a clarifying question for Martin or the room. Why were continuation frames a mistake? I have some gut feelings, but I think it might be worth discussing really to clarify the decision that we need to make here.
Mike, you want to give that one a go? You're in the queue.
Yeah, I mean, the short answer is that we defined a maximum frame size and the ability to negotiate down the maximum frame size for a reason, which is that in H2 you're on a TCP connection, and if you're going to make any progress from multiplexing, then you have to be able to switch between things. And the headers plus continuation effectively gives you an escape hatch out of that maximum frame size, and you can send an arbitrarily large frame that blocks everything else on the connection until it's all there. But unfortunately, the nature of HPAC being a continuous block that must be processed all at once, you have to send the entire thing no matter how big it is, or HPAC doesn't work. This might be a little different in that Exported Authenticators is not blocking any individual request that's already in progress. So we don't have to have the same requirements of nothing else in between. But that would mean we're building that would be like the to be continued flag, I think.
Yeah. So the other thing about continuation frames is that we currently have, I think it's 16K is the maximum frame size that would exists by default in most implementations, but we have a 3-byte length field on every frame. We could have said that the maximum frame size did not apply to headers and push promise for anyone using that, which would have been far simpler, but functionally equivalent to all the complexity that we added for continuation. We didn't do that, so here's where we are. This is another option for you in this space, which is to simply say, ignore that limit. It's on the control stream. That is an option. It does potentially cause stalling and various other problems like that, but yeah.
Right, which I mean, essentially we would be essentially keeping the language of the draft as it is, maybe adding that the maximum frame size for these particular frames could be ignored, and then you can just have a sort of infinite length thing. And yes, right. So the head of line blocking issue is the main
16
concern there, but
megabytes.
it might not actually be a huge problem in practice.
Yeah, so the limit would then become 16 megabytes, which is pretty big.
Yeah.
If you wanted to go crazy, you could make a stream for sending these things, and then you avoid all of those stalling problems. A new stream type is something of an undertaking in HTTP2, I imagine, but it's an option that's on the table as well.
I'd say if the main reason that this was a foot gun is HPAC, and that's not going to be necessarily relevant here, the to be continued flag seems kind of in play based on all these solutions. Seems definitely much easier than a lot of the other ones, unless there's a massive foot gun that I'm not seeing.
So it seems like there have been a few options discussed here. I guess we can follow up on the GitHub issue and the mailing list as far as which way we want to go here. But it seems like there's certainly more consideration over this point to be had. All right, next slide. So this is the last thing. This is maybe a little bit of a bike shed, but the current frame name is certificate, and it seems to make sense to rename it to server certificate or something that is more aligned with the scope that has been intentionally chosen for this document, and kind of open the door for extension elsewhere. So any objections to this, or should we just do it?
The queue is closed. No. He said bike shed, so.
David Skenazy bike shed enthusiast. No, just do it.
We know. We know.
Cool. All right, we're done bike shedding.
All right. Lovely.
Cool.
Is that you done?
Yep. Will be everything for now.
All right. Any other comments on this draft? Fantastic. It's good to see the progress.
Thank you, everyone.
Thank you. Okay. Next up, we have David Skenazy. Provided you don't turn into Pumpkin as scribe after your session. All right. Go on. Go on.
Now I can.
Okay. Can someone take minutes of David's session? This bit and this bit only. Okay. We'll take that.
Are you driving?
That never works. All right. Happy Wednesday, everyone. Hey, I'm David Skenazy, and let's talk about the wrap-up capsule. Next slide, please. So before we dive in, let's talk about intermediaries. This is HTTP. We all love our intermediaries. So a common type of intermediary that I'm choosing to call a front end, which is not quite the terminology in the HTTP spec, but is the one that we commonly deploy, is the one that it has the TLS private keys for the origin. And so from the client's perspective, the front end is the origin. They speak HTTP3 to the front end, and then the front end, turns out, behind it actually talks to another server, but that's within the operator infrastructure. And where it's relevant to this presentation, in the case where there's a bunch of gets on an HTTP3 connection, it sees those gets and then it forwards them, not necessarily all on the same HTTP connection to the back end, but it sees everything that's going on. It's inside the encryption, conceptually. And another type of intermediary, the one that I care most about these days, because we're building a few lots of them, is a privacy proxy, which in the HTTP specs, we call that more as a forward proxy, where the client has some level of local configuration, which decides to talk to this privacy proxy to, well, improve its privacy. In our case, the idea is it talks to some other websites to hide its IP address from the websites. But in this case, kind of the relationship is between the client and the privacy proxy, as opposed to in the previous one, the relationship was between the front end and the back end. And so in this scenario, the client establishes an HTTP3 connection to the privacy proxy, does a connect UDP request to there, privacy proxy turns around, opens up a UDP socket towards the origin, and then the client establishes an end-to-end HTTP3 connection between itself and the origin. And then through that, it could send GET requests. In this case, the privacy proxy has no idea that there's a GET in here because it's conceptually outside of the encryption of the orange arrow here. It just knows that it has an encrypted flow of bytes going back and forth. All right, next slide, please. Okay, so if we look at the first one, when we have a front end, a lot of the time the client is making a bunch of GET requests, and the front end then forwards them to the back, and at some point, let's say the front end is going down, it's doing a software update or is out of resources, it doesn't want to break anything on the client, but it wants to go down pretty soon. So next slide, please. It sends a go away. Pretty simple. And what that tells the client is you can finish these in process GET requests, but if you want to make new ones, you got to make a new connection. In practice, you'll probably land on a different front end that is part of the same infrastructure. And why is this important is that if your client's a web browser and your browser has requests that are mid-flight, especially if there's say a post, and they break mid-flow, the browser can't retry them. So what's important here to prevent those failures to become visible to the user, what you do is the go away tells the client, finish the ones that you have in flight so everything works correctly, and then for new ones, then take them somewhere else, please. And that works great. Next slide, please. But now let's look at what happens in the case of a privacy proxy. So same as kind of diagram as before, we have a bunch of these requests through this end-to-end HTTP3 connection to the origin, but then the privacy proxy has to go down because they let the manager write code and we have to do an emergency software update again. What do we do? Because we have the same problem where we don't want the client to like break mid get request. Next slide, please. Because from the perspective of the HTTP of the privacy proxy here, all it can do is pull the plug on this connect UDP and request stream and on the UDP socket. But if it does that, next slide, please. Things explode, sad browser, all. No, there's something else in this line. That's weird. I'll have to, I think emojis don't render properly. Anyway, all right, that's good. And so, sad browser. Normally there was a really frowny face on the client, but you can imagine it. Next slide, please. So, what am I here to talk about? It's a solution to this problem. So, the idea is now when the privacy proxy says, hey, like I need to like load shed, I'm gonna probably be going down. Hey client, can you please finish what you're doing? But for anything new, talk to a different privacy proxy while it sends a wrap-up capsule. Where am I zoning out on this? Yeah, and so anyway, things work on the browser. And another example of why this is useful for us is that on our privacy proxy, we use kind of anonymous tokens for the client to authenticate to the privacy proxy. And those tokens allow you to send some amount of bytes to the origin. And we don't want that to be infinite because we do rate limiting based on those tokens. And so if the privacy proxy reaches a point where the client's running out, similarly, we don't want to break things in a way that would cause user visible failures in the browser. So we send a wrap-up capsule. So a well-behaved client will wrap up, move over, and a misbehaving client, we would still yank the plug once they reach the hard limit. And so we get the security properties we want without actually breaking eyeballs. Next slide, please. Yeah, sorry, my AI game really isn't on point this Ietf. I haven't had as much time as usual. But how do we encode this? It's really simple. You put a wrap up in a capsule. I don't know, Gemini came up with this. And so why did we pick our capsule? Conceptually, between the privacy proxy and the client, as in the connect UDP proxy and the client, you could have intermediaries there. And for those, we want this signal to go through, and that's exactly what we built capsules for. And that's why it kind of feels like a natural use to send this signal. And then it's a capsule where that has no value, like the length is 0. All it says is wrap up. Next slide, please. And that's it. This is my last slide. Do people think this information is useful? Is this the right way to send it? And anyone interested in working with me on this? And then another discussion point is, like we saw this for Connect UDP. We have capsules on Connect UDP. It works well. There's a separate draft currently in this working group about Connect TCP, where if we add capsules to Connect TCP, that would also allow us to use it. So from my perspective, right now we use regular unextended connect for TCP proxying on our privacy proxies. And if we decided to have the option of using capsules for Connect TCP, I can say that we would implement Connect TCP to get this feature. This would be what we would want. I chatted with Ben Schwartz about this, and I saw him run out of the room, so I can say that he said anything I want him to say, but he seemed open to the idea of allowing capsules with Connect TCP. All right, and that's the end of my slides. Let's discuss.
Peter.
Piotr Sikora. So I think this is great, and it solves real issue that's happening with mask and everything. 3 questions, one comment. I think we should use the opportunity of Connect TCP and try to get capsules there, since it's solve this. One question that you didn't mention. I think the draft says that you can only send capsule downstream, right? So from servers and proxies down to the client. But I think it would be potentially useful if you also send it upstream, right? Because then potentially servers could send go away, especially in multi-hop scenarios, right? When you could, tell basically server to send go away on the inner stream.
Well, no, so the issue here is that if you send it upstream, you're going from the client to the proxy. The entity sending the go away inside the stream is the origin. You don't have a control channel to send this between the privacy proxy and the origin. Because at that level, you just have TCP or UDP inside which is all encrypted.
Well, potentially it could be mask-aware application, right? Maybe.
Still.
Let me think about it, but maybe no. Okay, and second question is, would it be useful to distinguish between relays that are not terminating and terminating either, on client side, on server side, again, in multi-hop scenario, because then potentially you could send wrap up and connection could be migrated without being interrupted on the end-to-end.
I see. So you're saying, to make sure I understand what you're saying, is that in this scenario, you have client, an intermediary, and then the privacy proxy, and the intermediary could send a signal to
Well, let's
the
say
two?
you have like, kind of like private relay with like, not even two, but like three proxies.
So the issue there is in the example of private
Mhm.
relay or IP protection like we're building, we're doing these nested privacy proxies, but it's the exact same problem as what you suggested with the origin, is that you don't have a control channel from the proxy A to the proxy B. Because from its perspective, it's just raw UDP, you don't know what's on there, it happens to be quick, or it's just TCP, which then has TLS.
All right, let me think about it. Thanks.
All right. Thanks,
So,
but yeah,
yeah.
that's definitely worth thinking through.
We have a somewhat long queue, just so folks know. We have a bit less than 2 minutes for each person in it, assuming no one else joins. We're going to close the queue pretty soon. So next up is Mike.
So, in discussing implementation of Mask, the last time we built something like that, one of our requests on the client side was to treat a go away on the proxy connection as also a go away on any internal connections. So stop using it and move on. And I feel like if we just wrote that down, go away is sufficient signaling, because that's effectively what the proxy is saying here. Unless you need a per stream, stop using this stream, but you can do a new stream and that would be fine. Is that the case, or are you doing this just because you want the end-to-end in case of intermediaries?
So what you described solves one of the two use cases. So in the case where your proxy is going down for maintenance, that works because you're conceptually sending this on all of the streams. So sending a go away to the client, that totally works. And maybe writing that down is probably a good idea too, if that's something folks are doing. But in the second use case that I mentioned, where we're putting a limit on how many bytes you can send per request, in particular per authentication token that's on the request, then you need a per request signal, and that's what this is.
Thank you for that distinction.
Thanks.
Next up is Eric Nygren. Okay, so you're done? Okay. Tommy.
All right. Eric had the same question as Mike. I'm just repeating.
Yeah, I also was thinking about the same question that Mike had. I think if we're doing that, maybe we want to have like a different name or semantic for this. Like when you think about saying like, hey, I'm telling you that you kind of need to re-up with the token, or like you're kind of running out of your credit. Maybe let's focus on that use case and really explore the motivation there. But in general, I want a reason that we can have capsules and connect TCP, because I think it's just like a useful way to extend the protocol. So like, let's use something around this as the first step there.
Cool. So on the first point, we can always rename. I'm always down for a good bike shit amongst friends. On the other, yeah, right now the capsule is as simple as possible. But the nice bit is there's a value field in there, and you could imagine having some kind of data in terms of, let's say, for example, as this is a byte limit, you could put the actual limit in there. So I've thought about that a little bit. I wanted to keep things simple as first, but we can definitely do that if we think. I think it'll come down to implementing this on the client and see if this information would change the client's behavior. because I thought through it, and in case I think once you receive it, you just stop whatever the limit is, because you don't really know how many bytes that GET request is going to be. But it's worth thinking through for sure, because there's something that can be done there. It's Lucas.
Yeah, I understand the problem. I think it is a problem, and this is a solution to it. We discussed on the list maybe other ways we could augment things, client signals or not. I think we don't need to resolve any of those discussions until this is like potentially an adopted working group draft. And, you know, if those things make sense, but they're too complicated, then we do them as a follow-up work. I think we can have all of that discussion. But to Piotr's points, I do see use cases for non-privacy proxies where we want to have controlled planes between proxy hops. So one of the problems we have now is that the signaling between those things isn't great. So if one of them goes down for some reason, planned or unplanned maintenance, everyone else has to kind of say, "Oh, was that which downstream of me went away? Which upstream did?" But also specifically in the proxying, like privacy proxying cases, we do speak to an origin, for example, but we don't speak to it directly. We offload that work to another service, and that service might have its own reasons for maintenance too. So I think, yeah, I think there's a lot of good work that we can be done here, and I'm willing to contribute towards that.
Awesome. Thanks, Lucas. Yeah, let's sit down and chat about those use cases. I think it totally makes sense to fit them in here.
I think this is a great proposal. I think it has real benefits. The only thing that I wanted to say was that I'd be a little saddened if this works only for capsules, because there are other HTTP things that are long-lived and probably benefit from this, like chunked HTTP, for example. So I'd prefer a frame-based approach.
Thanks. So the reason I didn't use a frame is getting through intermediaries. There is a potential solution where the way we will add capsules to connect is by defining a data capsule, where conceptually you put the data stream inside those frames now that are ordered, because you have to exchange it somehow. And it turns out that that solution could potentially work for any other method. I think whether you want to use capsules for other method, I don't know if that's great or not. Like the extra layer of encapsulation, that doesn't really matter because you already have 3 more underneath you of the HTTP3 level and the quick level and so on. But that would be one potential solution to that, where you still get the intermediaries and make it potentially usable with other methods.
Thank you.
Alan Frindell. One of the thoughts I had was similar to what Kazuho had, which is I've seen this problem with, we had some pre-web transport things that did long-lived stuff over HTTP streams, and having the ability to send go away-like behavior is interesting. So I think if we can work on something in that direction, I think it's good. Since I mentioned web transport, that was the other thing I wanted to say, was I think we have a similar capsule in web transport. Might be nice if we use the same one. Although I think maybe somebody was trying to get rid of the one in web transport, probably him. But anyway, this is interesting. Thanks for bringing it.
Thank you. And if we end up with the same data exchange, right now Drain Web Transport session has like an error code and an error string. So if we ended up with the same data, it would make sense to unify. Here, I'm not 100% sure, but I'm not opposed to the idea.
Eric Nakamai. Yeah, I think this is interesting. I think it also is worth, as part of this, looking at, are there other use cases go away doesn't cover well today, and like because it may be that having a new frame that kind of is that is an encouraging go away or wrap up that covers existing streams for long-lived connections, which has slightly different, could cover some use cases that go away doesn't handle today.
Awesome, thanks. Great. So, cheers. Where do you recommend we go from here?
It sounds like there needs to be a little more discussion, perhaps, but it sounds like promising discussion. So I think have some more discussions with people, maybe modify your draft a bit, have some, contemplation, and we can talk about adoption in the not too distant future, it sounds like.
Awesome, thank you.
Yeah. Sound good? Okay. I do need a new minute taker now. Both of our previous ones have expired. Anyone willing to serve the group. Lisa, thank you so much. It's at the note link in the agenda. Great, thanks. Now we're going to shift gears a little bit away from the stuff that's close to the wire and further up closer to the semantics. So first off, we've got Jeremy with No Very Search. Jeremy, are you here? Yes.
Let me see.
Can you approve this? Okay.
Quest it's
There we go. It should be coming up now.
hopefully that worked.
Yep, go for it.
Hi, so I'm Jeremy. I'm on the Google Chrome team. I'm here to talk about No Very Search. So basically, some background on a lot of this is going to be familiar. In practice, the URL's search component is treated as a list of key value pairs, even though some specifications just treat it as an opaque string. This is how it's typically released on the web. Just as HTTP responses typically don't depend on all of the request headers that were sent by the client, they also often do not depend on all of the URL query parameters that were sent. Caches work best, and there's a particular cache that I'm interested in, but when they know as much about as possible about which cache responses can be used to satisfy a request, because it might mean that you're able to serve a response from cache when otherwise you couldn't. And the quick survey suggests that existing cache software, caching proxy, CDNs, and whatnot, do support ignoring query parameters in some way, even though HTTP doesn't provide a cross-vendor way of the server indicating this to its client, which may be a caching proxy. HTTP does, however, provide a mechanism for request headers in the form of the vary header, which lists the request headers upon which the response depends, or star. Today, Chrome now does support a way of varying on the query parameters for navigational prefetch and preender, which is the No Very Search header that we implement in that cache. But the concept seems generally useful to HTTP cache implementations, browser caches, proxy, CDNs. So it was suggested that we bring this to Httpbis. So why do clients send these meaningless parameters that the response doesn't even depend on? There's a number of reasons. One of the common things is that the server processes the query parameters but doesn't care about the order. It treats it as a map or a multi-map. So the order, so A equals 1, B equals 2, and B equals 2, A equals 1 have the same meaning to the server, and therefore it doesn't actually matter which order the client sends them, and it would be acceptable for the client to use a response where the keys were in a different order. Some parameters affect server processing, but not the semantic meaning of the response. For example, they might request load balancing to a particular backend instance, enable debug logging, or change request priority. None of these semantically change the response, but nonetheless, the server is interested in receiving them when it is processing a request. And on the web, it's common for parameters to carry data that is actually intended for client-side processing. For example, by analytics software or to initialize stuff on a web page that sometimes is used in the ref, but can exist in the query as well. And those don't affect whether the response is suitable, because once the client processes the response, all the client-side processing from that point is going to be the same. So what we implement is a header called No Very Search. It's inverse in sense to vary because vary basically does the opposite thing. The default for HTTP is to vary on none of these request headers, and the default for query parameters is to vary on the entire query along with the rest of the URL. It's a structured header. You can indicate that your response doesn't depend on query parameters at all, doesn't depend on their order, or doesn't depend on the values of particular parameters. You can also say that in the opposite sense. These are joined by commas, so when the automatic concatenation of HTTP headers works basically as you would expect. This is something that we implement only in the prefetch and pre-render caches for navigations, not in the normal HTTP cache in Chrome right now. That shipped for prefetch in Chrome 1.2.1 and for pre-render in Chrome 1.2.7, which is relatively recent. 1.2.1 was about 6 months ago. It's implemented in Chromium, which means that it's likely that other Chromium browsers are shipping it, but I haven't checked other Chromium-based browsers shipping schedules. The specification is a community group draft within YCG, within the W3C, but if this is something that's interesting and if it makes sense to move some or all that specification text into the IETF scope within HTTP working group, that is basically what was suggested that I open the possibility of. What would remain to be done? I've done some work to reformat as an internet draft, but there's different conventions and whatnot between the two groups. The specification currently discusses how to parse this header and what it means, but that doesn't actually tell HTTP implementations how they should modify their caching behavior, which is going to be RFC 911. So if we wanted standard HTTP caches to respect this header, some sort of this is how that affects RFC 911 would be required, including how multiple matching responses should be handled. In general, that's treated as a bit of a hand wave, but any issues that we didn't encounter in the kind of prefetch cache, but which would affect other parties' implementations would be interesting, as well as any extensions to express semantics that people think are important, but which aren't yet captured in the feature as we currently envision it. And then I've just got some links to the explainer on YCG, the internet draft, and the YCG draft. The YCG draft, the internet draft have the same text modulo, the need to fix up how links work and that sort of thing. So those are the same document. You'll find yourself very bored if you read both of them. That's all I have prepared.
Great, thanks, Jeremy. Any responses, comments, questions in the room?
Curious, Michael Tumim, I'm curious if you have any data on how this improves caching performance in practice.
So the primary use case I'm aware of, basically we wouldn't have cache hits at all, and so it sort of is a fairly radical change. I don't have any data about other applications. So like, for instance, Google search uses this in some cases because we want to mark our prefetch requests specially for different server processing. And without the ability to say that that doesn't affect the response, the prefetches never match. And so the cache hit rate is 0 and the prefetches are completely wasted for that use case. So that is, a 0 to a very high cache hit rate, right? But in terms of the general applicability across other kinds of requests, I don't have any data. I just have vibes.
But you're using this for Google search, you're saying. So like when I'm typing in a search and it's live updating results, is that the case?
Yes. So there's basically some cases where some of the you're typing in a query and we will prefetch a search result page for that. And then when you ultimately click on the query that we think you're going to make, then that response is used. Does that answer your question?
Yeah, it's really helpful. Thank you.
Anyone else?
It's sec fetches. We do send a sec purpose header indicating that the request is a prefetch. The reasons why this search at least wants more granularity than that for internal reasons. I'm not sure I'm at liberty to share in detail. The other applications, obviously, knowing that it's a prefetch isn't necessarily enough. But yes, we would expect that there are some applications where people are satisfied with the request header. To answer Martin's question in chat.
And just speaking as myself, I'm very interested in this because it's very common practice in proxies, caches, and CDNs to do this in a proprietary way. And so having one way to do it is nice, and having one way to do it that's aligned between intermediary caches and browser caches is very attractive, I think. So I'm quite interested. I think we're suffering from the fact that most of the folks that I'm looking at in the room are more interested in the transport side of things. And especially we don't have a lot of caching people here in the room. And so what I might ask is the people who are representing, especially CDNs, if you could go back to your caching teams and see if there's interest in adopting something like this, that would be really good information. I'm going to go and talk to my caching team. I suspect they will be interested. And then we can also take it to the list perhaps and get some. I know a lot of especially the independent proxy cache vendors are on the list, and we can get their feedback. But again, I think this is very interesting and a pretty obvious win to take forward. Any other feedback in the room? Okay. So now with my chair hat on, I think we'll probably take it to the mailing list, have a bit more discussion. And if things look promising, I don't see any reason why we can't do a call for adoption and formalize that pretty soon. Yeah. Okay. Anything else, Jeremy?
Oh, that's everything. Thank you.
Great. Thank you very much. So stay tuned. We'll get back in touch. Next up, Johan, also remote, revising cookies.
Hey everyone, can you hear me okay?
Hi. The audio is not great.
Is that great? All right, let me try to fix it. Not sure.
Yeah. If I say meet echo, can something magical happen? I don't know. Meet echo, Mickey.
We can just turn down the volume.
Yeah?
Yeah.
Yeah, you do that. I'm not touching it. And Johan, do you want to share your slides or should we share them for you?
Can I control them if you share?
Sure. Well,
Cool.
That sounds a bit better. Okay, go ahead and make the request and we'll. How do
Wait.
I?
Yeah, I can also just share them if you.
How do I approve this? It's taking a little while.
Oh yeah, no, I see it now. Thank you.
You need to confirm.
Okay, there we go.
Yeah. So asking again, can you hear me okay? Do I need to change my input device or something?
That's better now. Thanks.
Okay, cool. Thank you. Yeah, so hello everyone. I'm Johan, working on Google Chrome. And over the last, I think, 1 year or so, I've been working with Anif and Kestrin, looking at cookies again. And as part of the sort of bigger architectural change that we call cookie layering. And I think it's at the point where we sort of want to start talking to this group about it and want to sort of work on the draft that we have together with this group, and also obviously want to get to adoption of the draft with the group. And so I wanted to give you a really high level overview of this effort and the draft that we have, and happy to dive into details as needed. And please feel free to ask questions afterwards. All right, so yeah, as you know, we. I guess I could go next slide. Yeah, we just put 6265biz into working group last call. We just got through working group last call after I think 10 years of overall development, which is really, really great. So really appreciate all the work of all the editors. And now we want to do another one. Why is, I think, a very valid question at this point. And so 6265biz, added, obviously, over its lifespan, added a lot of really great innovations, particularly just, from my perspective, really in the browser security, and privacy space, same site none, or just generally, same site attribute and all that. It came with 6265biz. The way it implemented those things, unfortunately, it is done through what we call layering violations, right? So in a lot of ways, it tries to describe browser behavior in a way that theoretically, sort of like in a way that browser specs would, but it's not a browser spec. It's an RFC, and so that both causes, I think, sort of a bit of confusion in browser land today, and also we really feel the pain of that, trying to standardize a bunch of other things that have come up in the recent past and that we're working on, such as third-party cookie blocking, the cookie store API, the storage access API, the partitioned cookie attribute, and all those, right? All of that should have components in fetch and the HTML specs that control how it works on a browser level. Unfortunately, it's very hard for us to integrate with the cookies RFC because it doesn't really provide that kind of surface. It's really right now like the best option that the browser specs have is to more or less hand wave and hand it over to the cookie spec, which then tries to do things like walk a document tree or something like that without actually being a browser spec. And I can imagine it also like not being a non browser user agent developer, but I can imagine this also creates some unnecessary overhead for non-browser user agents overall. And additionally, we have a bunch of deferred issues still from 6265bis. I think that's obviously at some point we need to make a cut and publish a document. I think it was in a great state, but we had some remaining disagreement on things like same site none, which we need to work out, and I think another document is a great way to do that. So how are we going to do this? Just the rough plan here, and again, I want to keep it high level, but happy to dive into details as needed. Is we want to define sort of a concept of a cookie store in the cookie spec. And there's already a concept, I think, but sort of make it more explicit that that's sort of the main surface, the main normative surface that the cookie spec, the cookies RFC describes. And then we have some shared or some operations in this cookie store, such as adding a cookie or deleting a cookie or something like that. And then we make expectations around how specs and implementations should deal with these operations and how sort of they should use them in network requests. And for browser user agents, that practically means that we largely defer to HTML and fetch in order to use these operations and store, delete, and all that, depending on the network request that the fetch or HTML specs are handling. And for non-browser user agents, the cookie spec would remain pretty concrete in terms of steps to do and how to handle, set cookie or cookie headers specifically. Yeah. And so this is really it. Not a lot. We have a draft that we would love to get adoption, eventually get adopted eventually. And in the meantime, we very much welcome y'all to take a look and review it and read through it. There's some rough edges for sure, and there's also stuff that we haven't fully integrated yet that's on the to-do list, such as the cookie store, the cookie store API. We called our concept also cookie store, which is very confusing. We're considering changing the name, but there's cookie store API shipped, I think, only in Chromium right now. Which has, again, like a lot of these sort of hand-wavy formulations around like how things might work with the cookie spec that we're trying to fix up, specifically around observing cookie changes in JavaScript, which is the thing that this API exposes. So some of those things aren't fully specified yet, but I think we have the main architecture sort of laid out and the main structure of the specs. If you want to take a look, it's definitely a big change already to 6265bis. We're working on top of 6265bis, and I think we're planning to. I'm not super familiar with the process, how it works, and like the right semantics, but I think we'd be sort of replacing whatever number 6265bis will get once it gets published. Yeah, and that's it mostly for me.
Great, thank you, Johan. So any comments, questions, clarifications in the room? Expressions of interest, doubt, heartbeat, fear? Yeah. Okay, I think people are digesting. Stephen.
Stephen Bingler, Chrome and current 6265-bis editor. Speaking as an editor, I think this is a great step forward and directly addresses a number of issues that I ran into working on the current draft.
Yeah, my impression is there's been a fair amount of background discussion about this and then recognition that it's necessary and perhaps thankless work. So, yeah, we'll have to have some chats with people about, who's willing to put energy into it, which is one thing. I guess the question in my mind is when we did 62, 65 bis, we created this process to make sure that any large changes to the spec, especially new features, were vetted as separate drafts first. I'm not sure that's necessary at this point. The nature of this work seems a little bit different. This is more maintenance, I think, as I'm understanding it. So, Johan, it sounds like you're not quite ready to say you want adoption of the draft, but you're trying to give people a heads up. Is that a reasonable characterization?
I mean, we definitely want to work on the draft in the working group, right? So happy to get adopted, or ask for request adoption at any point, really. But yes, this is the first time I was showing this to the group, right? So I'm not expecting people to just, say yes right off the bat. Happy to continue this conversation. Also, happy to join virtual calls, whatever, to talk more about it. All in all, I think what we expect to continue working on this, in the working group, and I don't think we'll get more ready personally, but yeah.
Okay, that's good to know. And yeah, I think Tom and I will have a chat, and we might reach out to a few people and figure out next steps from there.
Yeah, thank you for doing this, and we'll discuss more. I think one of the main things I'd be interested in is how do we do this strategically so that it doesn't take quite as long as our previous cookies updates, to make sure that we get the right energy and attention, and also make sure that the scope that we start out with is something that is achievable in a relatively short time frame. Less than a
Yeah,
day.
that's a great point, and I think we should talk about that for sure. I'm not interested in another 10 years. And yeah. Oh, yeah, Stephen, go ahead.
It's actually almost 8 years. I have a meta comment to whoever's taking notes. It's 6265 bis. Thank you.
Yeah, that's my fault. I began calling it 6265 bis at some point, and it is 6265 bis. I wanted to just briefly remark that there are some new features we would be introducing, I think, as part of the draft. For example, the partitioned attribute, right? Which has its own RFC, or it doesn't have its own RFC. It has its own ID by Dylan Cutler. Just wanted to, just for completeness sake, mention that. But I think apart from partitioned, most of the things aren't necessarily net new.
That was my impression too. Yeah. Okay, so it sounds like we'll have a little more discussion, and I'll try and make some progress on this. And thank you for putting energy into it, because, yeah, this is important work, but it's not necessarily glamorous. So thank you. Glamorous.
Thank you all.
Yeah. Great. So I think we're done with that. And our last scheduled presentation for today, Michael, we've got HTTP resource versioning.
Do you want to share the slides?
Yep, that's one.
I will grant you, and then you can scroll through and find yours and click confirm. Yeah. Hey, we're live. All right. Can I pull this out? I'll just do this. Okay. Great. So today we're talking about versioning for HTTP resources. And so for those of you who are in Prague 2 meetings ago, this is a continuation of work towards adding synchronization features to HTTP. So so in the Braid group, we've found that we can, from the user's perspective, give every URL the functionality of a local first Google Docs. So you can have multiple writers editing it, you can have collaborative editing,
You can have multiple writers edit things offline. Everything can merge. It's really nice. And it requires these 4 independent extensions to HTTP. Each of them is independently valuable. And so today we're just going to break off the versioning extension and talk about versioning and how that is independently valuable for HTTP and what it looks like. So first, I'll take you through the problem. We'll have some discussion on the problem statement. Then we have a spec with a proposed solution, and we can talk about the feasibility. So here's a basic problem. HTTP resources change over time. It's a state transfer protocol. REST is representational state transfer, and that state changes. And each change to the resource creates a new version. And we don't have a term of a version yet, like in the specs of HTTP, but it'd be really nice to have this idea of a version. So version history can be linear, like on a single computer, but then over the network, it branches and merges like a DAG. So when you're doing Git stuff, like you have a version DAG. So the basic ideas of what versioning looks like. And this does exist in HTTP in a sort of a smattering of ad hoc uses for different, that serve some subcases of the purposes. So the last modified header, it gives you a timestamp for a resource. And by the way, when we're talking about versioning, we're talking about versioning for resources, not for APIs. So like an API will have a whole set of URLs and data schemas. Not talking about that. We're talking about a particular resource changing over time. So last modified gives you a timestamp. Now that's really useful, but if your resource changes multiple times per second, there's no way to distinguish because it's only at the resolution of a second. So e-tags give you a more precise way of marking a particular version of a resource, but they are specific to the content and not to a moment in time. So if your content changes from foo to bar and then back to foo, it might have the same e-tag again. And neither last modified or e-tags give you a version history. They don't tell you which versions happened before or after other versions. And that's something that you need for a lot of purposes, like collaborative editing. And in practice, programmers want to be able to store and retrieve a whole version history of resources, and they just put them into new URLs. And so you'll have a URL per version for this or that. And there's been a bunch of approaches to try to standardize or formalize the semantics, how you're doing that with WebDAV, Memento, link relations. So here's a matrix of our current smattering of approaches to versioning. We've got the different approaches as columns, and then a bunch of qualities of them as rows. So we want to be able to store and access history, okay? Last modified and e-tag don't give you semantics of history, what happened first or later. You can't store and access them. We want to mark time, not just contents. We want to have support distributed time so that multiple clients or servers or peers can modify it at the same time. We want it to be independent of allocating new URLs. We want to have the semantics of a resource changing over time, not multiple resources for each change. Although you could also add that later, but that should be a separate design decision. And then there's this, I'll talk about customizing. But so if we get a general version, functionality for versioning that can fill in these gaps, I'm going to show you some examples of what we can get in HTTP. So we could have incremental RSS updates so that when you're polling an RSS feed, you can say, here's the version that I have. Now just give me the diff. Instead of every time the feed changes, I have to re-download all of the feed entries all over again, including the new one. We could also host Git repositories directly on HTTP. There already is an HTTP Git protocol, but there are two versions. There's a dumb version and a smart version. And if you want to get incremental updates, like you do a pull, and you want all the new stuff, just the new stuff to download, then you have to use a smart version, which goes outside of HTTP in order to negotiate that. We could bake that directly in. CDN, so like the Internet Archive could archive websites and resources, and then proxies and caches could store all those old versions, and that'd be really nice. Patch requests, so there's a bunch of issues with patch, put, and post that when you're trying to patch, when you're sending these requests, they need to know what version they, like if there's a race condition or the requests go out of order, then they have to specify an if match or if not match e-tag so that you know which request, so that the request only applies to the right version. And you can't, if you get a versioning built into that, then they can apply to old versions, not just the current version, and then the request fails. And so this could provide your basic mutation requests could function automatically behind the scenes and just run and do the right thing. And that's what you need for collaborative editing. So first question is this problem interesting to the working group? Here's some design goals that we'd want to have in a generalized versioning architecture. And how much time do we have?
We have a reasonable amount of time.
Okay, cool.
Any thoughts or responses?
So I think earlier you
Sorry,
mentioned.
can you identify yourself?
Oh, I'm
please?
sorry, Josh Cohen. I think earlier you mentioned web dev. So like, I mean, in general, like how would you compare this to that in terms of like the problems that it solves? Because I mean, I remember when that was done. I mean, it's very complicated. All the different scenarios. Anyone else here from web dev days?
Lisa DeSoto.
Oh my God, it's you.
Oh, great.
The
Nice to meet
author
you,
of
Lisa. Wonderful. Yeah. Yeah, it's attacking a very similar, addressing a similar problem as web dev. But part of the complexity of web dev is that you have separate URLs for every version. And there's even a separate URL, I think, for the version history. And if you want to find out, for instance, what is the current version of the resource, you have to do a prop find, pass in some XML, get something back, and then do another request and then get something back. This is a much simpler, you just do a head request and you get the version ID. So we'll see that in the second half also.
Okay.
I guess I'll add myself. Sure. So adding myself to the queue and speaking only as myself. I guess I wonder about the use cases here in that, yes, Git is a thing. And if you have a Git repo, you have this full history in all the different versions and you can do interesting things with them. So, if you have a Git repo, this is just kind of surfacing that. But for a lot of other cases, you're not going to have that fullness of the version history. You're going to have a selection of it because there are practical considerations, a cache somewhere. Or even if I have an RSS feed on my website, I probably don't want to keep every version of that feed document over all of history. And so then some trade-offs need to be made and your protocol becomes potentially a lot more complex. So then if I look at these lists of use cases through that lens, I'm wondering how many are really going to be compelling at this point.
Okay, so maybe this is a question of how feasible it is to implement it without additional. It's true that these use cases do require some additional things too.
Okay, just,
yeah.
Just a floating thought, really. That's
great.
Yeah.
And we do have a lot of implementations too. For most of these things, we have implementations that work pretty well, and I can share some of that practicality.
I'm Eric Naganakamai, just kind of tossing in use cases. I don't know if these are worth the complexity, but other ones I've seen are for CDN partial object caching. It's really messy to get a consistent object. Like you want to be able to have multiple large objects both cached simultaneously and be able to fetch those from origins. Having a model here might be able to help with that. And a similar one is for object storage systems like the S3 interface, where you might have different things uploading different versions. Being able to have a versioning model like this could be potentially useful there, kind of natively within the protocol for resolving conflicts.
Yeah, great. What is the partial object? Is that like you've uploaded part of an object but not the full thing?
So for CDNs that have downloading a very large object, oftentimes they'll only store ranges of that object in cache.
Yeah.
And we'll do range requests to fetch it from the origin.
Yeah.
But the challenge becomes when that object changes on the origin you're fetching from, you don't want this Franken object in your cache. And when you're serving it out to clients, you also don't want to be serving clients a Franken object. So being able to cache different, and when you have something that's kind of in this inconsistent state, you can like e-tags will help there, but you can still get into messy situations where you don't converge towards a single object, and being able to have a versioning model so you could get kind of within some short period of time both objects as two distinct things but with separate versions, and being able to talk about that more usefully could be helpful.
Excellent. That's a great point. Yeah. And that also connects. I'll show a resumable uploads example, which I should have put on this list also. And because you can also, let's say that you have mutated your object, part of it's cached. Now you patch another part of it. The semantics that we have here will let you keep that same cache of the old part and know that the new part's just this new, a new patch with, and that doesn't invalidate the old part that hasn't changed. Okay, so I'm hearing some interest and also some thoughts about how is this actually going to be feasible in practice. I guess I'll move on. Cool. Okay, let's just go. So okay, so here's what we want. We want versions that mark points in time, not content. Okay. We want time that can branch and emerge. We want a history of versions that you can store and access. And something I haven't mentioned yet, we want to be able to have different time formats because a lot of distributed systems have specific algorithms and optimizations that we can encode there. So I'll show some of that. And we don't want to require additional URLs. We don't want to, but we want to be compatible with that. So here's the proposal. Pretty simple. We have two main headers. We have a version header and a parents header. Both of these headers store a version. Parents header stores multiple versions, and that's how you get the DAG. So, but at the same time, a version is defined as a set of version IDs. Okay, you can think of these as events in physics. These are the raw mutations that happened on some computer at some point in time. And a version ID just has to be a unique string. And then a version type can define the format of that string. And that's going to enable a bunch of fantastic optimizations that are making CRDTs practical these days. So we're just going to take those headers and we're going to now extend the regular methods get, put, post, and patch with the version semantics. So here's what it looks like. So top example, we can put a new version with some parents. And there's the body, and that is going to add a new entry into the history. And so you can just take a regular put, you can add the version and the parents. Great. Next example is getting a version. So I want to get a specific version. I just add the version header. And then the last example, this is something that's very hard to do with WebDAV. If I want to know what is the current version, I can just say head, and the version header tells me what the current version is. I think there's an example. I think I read this up on Hacker News once. The WebDAV equivalent is like, I don't know, 50 lines or something. Okay. So now the semantics for these headers, there's a nice symmetry to it for both get and put. So we're going to look at get, and then we're going to look at put, post and patch. So if you just do a regular get, it says the semantics is give me the current version. If you say get with a version, the semantics is give me this version. If you say get with the parents, it says give me updates since that parents. And so that might be just a patch, but it's up to the server to determine how. We can have additional semantics later to constrain that. And if you say get with version and parents, then it says give me the updates from these parents to get to that version. And so that can give you a range of history. Likewise for put post. Oh, do you want to speak, Mark?
Just a question clarification. If you can go back to the get slide. So it looks like on that second box, the version header is modifying the semantics of get. Is that the case?
Yes.
Okay. So how is that backwards compatible with the deployed web?
If the server does not understand that semantics, then it returns a response without the version header.
Right, but it might be going through a cache. And
Yes.
the cache won't understand it.
That is okay. Yeah.
Yeah, so it will return the representation that it has in cache. So
Yes.
Is the client expected to notice that the version is different?
Yeah, I think if there's no version header in the response, because the cache won't return a version response.
Or well, it might. It just might be a different version.
Oh, yeah, that's true. Okay, yeah. So then the client would
Right.
recognize that.
So,
Yeah.
so it's responsible for rectifying that effectively.
Good point.
Yeah.
Yeah.
And I'm a little worried that it doesn't have a way to force the issue, as it were.
Okay.
Yeah. So just
Interesting.
Okay.
Great. Thank you. Okay. Okay, cool. So so semantics for put. If you can put as normal without a version. You can also put and say what version it is. You can also put and say, if you put with a version, but you don't specify the parents, then the server presumes its current version is the parents. If you put without the version, then the server can make up a version ID for it. Or you could encode everything. This is kind of a side topic. So this is multi-response is a different proposal that I haven't written up, but just to sketch out, if you want to request a version history, then you need some way for the server to return multiple responses or multiple things. So this is just a sketch for that. And there's also, I haven't mentioned, there's a current version header where when you're returning multiple responses, or if you're putting a bunch of versions, you can say which one is the current one that you have, which can be useful. Okay. Okay, so now here's some crazy things that you can do with version type. So distributed systems have a lot of different ways to represent history, and they can do different kinds of optimizations for different cases based on that. And because each version ID is an opaque string, we can now have a version type that describes the contents of that string and gives you all these abilities. So on the list, we had a bunch of comments from CRDT people who were saying, this is not going to be optimized, but it is going to be optimized using this stuff. This is how you optimize it. So for instance, some systems use a vector clock. If you have a known set of peers like Mike, Stefan, Greg, then you can encode your version as a vector clock. And this lets you compare any two versions and know which one is newer than the other without looking at the entire DAG. And you can do that in O of one time, which is pretty nice. But you have to have a constrained set of peers. The second example, you can have a run length encoding version type. And run length encoding is what lets CRDTs become pragmatic. So this tells you that each version is an agent ID like Mike, and then the number, which is the clock for Mike, and that tells you, so now if Mike, this optimizes because when we write text, for instance, we tend to go left to right and insert huge strings of characters, and each character is going to have the version of 1 plus the previous version, which means you can infer them and you can throw away all that intermediate metadata and know what it is, which gives you huge compression. And the last one, version type get, lets you say that the version is going to be a hash of everything, and then you can verify the hash. So there's all these different properties that you can encode. How much time do we have now?
Still plenty of time.
Okay.
15 minutes.
Oh, great. Okay. So this is relevant to the group since we're discussing resumable uploads. We can do a version of resumable uploads, at least the basic version, without any additional headers by just defining a new version type. And this is taking advantage of the basic symmetry between time and space, that when we are uploading, let's say 1 byte at a time. And so across time, basically time is proportional to the length of the file that is being uploaded. So we can have a version type called a byte stream, which says that this resource is append-only sequence of bytes. And now we know that at time t, the length of the resource is t bytes. And so we can use that on the client. Let's say we're doing an upload, and the upload gets interrupted. Then the client can just ask, well, hey server, what time are you at? What's your current version of this resource? And the server can say, well, I'm at time 500. The client now knows that you've got 500 bytes. And so taking advantage of the symmetry between time and space for a streamed upload, we don't need a new header. And there are other nice symmetries for CDNs, as you're talking about large objects. We're changing large objects, especially with range requests. We can reuse a lot of ranges from patches at various points in time. So that's kind of nice. We talked about Git. Okay. We've got a lot of implementation. So for instance, this is a Chrome window on the left with collaborative. This is a text file at a URL that is also a collaborative editor, because we've added collaborative editing to the resource itself. And so you can open your Chrome DevTools and you can see a version history with a DAG. You can go offline and edit it. You go back online, all your edits get merged. And we also have this working in regular web apps where all of the state is hosted in this way. And so then you don't have to use tons of layers of different JavaScript packages to stream your state over a WebSocket. So just some examples. It's working. We have working feeds. You can reconnect to the feed and get the latest stuff. And back to questions. So that's a sketch of the solution, sketch of the problem. These are the questions. Are we interested in this problem? Do we see feasibility in the solution? And long term, what does it take to get towards adoption?
Okay, so let's open it up. Any discussion, comments? I am seeing some interest in the chat in this problem space. Lisa seems to want to say something, I think. No? Okay. Chris Lemons.
Yeah, I'll say at the mic what some of what I said in the chat. I have interest in the problem space. I think you're solving a real problem, and I think there's value in having a standard solution to this problem, as opposed to what we currently have, which is a lot of different ways that genuinely work, but they don't interoperate. And importantly, they don't operate well with caches in the middle. And so I think it's going to be important that when we look at this work, that we think hard about what caches in the middle does to it. And I think, Mark has made some observations about what the current implementation is likely to do to caches. And I think those are spot on. And we're going to need to think about that if we want to move this work forward. But I think thinking about the intermediaries is super valuable here, because that's what the standardization buys us, in my opinion.
Great points.
Yeah, and just to piggyback on that, I think personally, it's the integration into HTTP is where this group can provide the value to make sure that it plays nicely with the rest of the ecosystem. And all the different features. I mean, this is always the problem when you introduce a new HTTP feature. It has to mesh with all the other defined features in some fashion. In my mind, the big question here is how do we chunk this work up so that it is manageable and of the appropriate granularity? And I'm thinking probably there's a versioning framework and one or two versioning schemes that you'd want to ship to start with. And there are other further out things like the byte ranges stuff you talked about scares me a little bit, because we already have a way to do that. And the multi-status stuff, there are some scars around that we have a lot of lived experience around, and maybe we don't want to repeat that. But those are separable discussions, I think. And so if we can focus on the framework, I think this has a lot more chance of viability, because I am seeing a lot of interest in it in the general problem area. So next up, please.
Kohei Ueno, one thing that might be tangent to this problem is that we struggle with JavaScript resources. So in particular, we try to cache compiled resource, while it may be difficult to make it tie to the previous versions of the compiled resources since we don't really know like what has changed since then. So we end up completely discarding them and compiling the new one again. And since JavaScript resources tend to get larger and larger, we hope to reuse the previous one. With this versioning scheme, it may be a step forward in that direction, where the delta is much clearer, and we can thus only compile the delta and apply it to the latest version.
Okay, so to clarify, it's a little bit hard for me to hear, I apologize, but I think you're referring to compiling JavaScript resources?
Yes.
Okay, yeah, and then as one updates, and you can handle the deltas better if you have good versioning.
Yes.
Great. Yeah. Thank you.
Tommy Pauly, mainly speaking as chair here, I just kind of want to echo what Mark was saying about kind of keeping the pieces separable, and also just like thank you for in this presentation kind of focusing on a particular flow and having it be very clear. I think this type of approach compared to some of the other iterations of this, like it's going to be easier for the group to digest and understand. And I think there's aspects of the framework we need to do, but also teasing apart what are the individual building blocks and how can we do the technical work on those building blocks separately and clearly will help make it successful. So this is a good step in that direction.
Cool. And then I think what I'm hearing, I think Mark's comment is definitely resonating in my mind, finding something that's going to work with existing proxies. And I think if I could probably get some help on just getting a good framework for testing, I think that would be really helpful. Okay. Maybe if we had that demonstration for the basic get, put, patch of versioning, that would be a good step.
I suspect that people need a little more time to kind of let the draft soak in and think about the implications, and that could be a little bit of a process we need to go through.
Okay.
It's and I know that's maybe a little frustrating because you've been doing this for a while now, but let's everyone take a look at it and maybe give some more comments, but keep the discussion going on the list definitely, and we can also have a background discussion about what the path forward might be.
Cool.
Okay.
Yeah.
All right. Any other discussion? All right. Yeah.
Anything on this
draft?
on
Yeah.
this presentation?
Yeah, this is the end of the press. This is the end of the presentation, so any thoughts are open.
Right.
On this presentation.
So I was looking at the draft and the subscribe, notify stuff, like the subscription stuff.
Yeah, and that's out of scope for the versioning, but it is. I'd still love to hear about it. Yeah.
Okay, we can talk offline then.
Okay.
Sounds great. All right. Well, thank you, Michael. And thanks everybody else. Thank you to our various scribes. And we'll hopefully see everyone, or at least some of you, in Dublin, I think. Yeah. Thanks.
Thank you. Ended up with the right. I mean, we ended early.
Yeah.
Last time, but this was
good.
good.
This was good. We had a nice amount of discussion.
Yeah.
And I feel like there is still some things that we're looking at adoption here, but the number of big chunky ones is I think cookies is going to be a big chunky one. And if we do eventually adopt this, that's going to be relatively chunky too, I think.
Or many chunks that go together.
Sure.
Like a series.
Yeah. But I want to make
But
sure
it's not
that
quite there yet.
it's not quite there, but it's definitely showing promise. Yeah.
I think this is. It was a nice decomposition.
I mean, the problem is